We want to determine if the series converges or diverges, and we see that this will make this an alternating series. And so now as we consider the requirements to use the alternating series test, first of all, we need to have these terms. There's actually 3 requirements. I think the video said 2 because it said the b sub n's were greater than 0, but didn't specifically list that as a requirement. But one of the requirements is that these need to be positive terms. This will make the signs alternate, but these parts will be positive, and we meet that requirement. These also need to be decreasing. So any successive term needs to be less than or equal to the preceding term. Now, does that appear to be the case here as we let n go from 1 to infinity? And that does appear to be the case, and we could actually prove that or show that with calculus, because we could look at the function that had these integer terms, and we could look at it as x to the negative 1/2. And if we took the derivative of this function, it would be negative 1/2 x to the negative 3/2, which is negative 1 over 2 x to the 3/2. And if we are just simply looking at n being positive integers, this will always be positive, but we have a negative on here, so the first derivative is negative, which tells us that the function is decreasing. So we meet that condition. And then our last condition, if we looked at the limit as n goes to infinity of the terms here, is that going to 0? And the answer is yes. We can see that we have a fixed numerator and the denominator is becoming larger and larger. So we meet the conditions of the alternating series test, and therefore this series converges based on the alternating series test.